Blockchain. You hear that word everywhere, right? But what actually makes it so secure? What's the secret sauce that makes it famously tamper-proof? Well, today we're going to pop the hood and take a look at the cryptographic engine that makes this whole thing run. So here's our game plan. First, we'll get the big picture view of what a blockchain even is. Then, we're going to zoom right in on the individual blocks themselves, uncover the magic of something called hashing that glues them all together, look at the unbreakable rules it has to follow, and finally, see how it all combines to create this incredible fortress of digital trust.
All right, first things first. What is a blockchain? Before we get lost in all the technical details, let's just get a really clear, high-level understanding of what we're actually talking about here.
Okay, so take a look at this. From start to finish, this is basically the entire life cycle. It starts with creating a block, it involves ledgers, it gets spread out across a network, and it's all verified by something called proof of work. This is the entire journey we're about to break down, piece by piece.
The most important idea to grasp is that a blockchain is basically a shared digital notebook. You can almost think of it like a digital notary. Every single transaction gets written down, it gets a timestamp, and then, this is the key, it has to be verified by the majority of people in the network. That consensus makes it almost impossible for one person to sneak back and change the records.
So we kind of get the chain idea, but what about the blocks? What's actually inside these digital containers that makes the whole system tick? Let's dive in.
You know, the easiest way to think about a block is like a digital safe. It's just a container that's built to hold data. But here's the thing, once that safe is locked, the stuff inside becomes immutable. It can't be changed, it can't be erased, like ever.
So every single block has two main parts. You've got the block data, which is exactly what it sounds like. It holds the list of transactions, TX1, TX2, and so on. But the real magic, the real security, is in the block header. It's got a bunch of administrative info, but the most important piece of all is that little thing called the previous block hash. That is the cryptographic link that holds this whole universe together. And this is the chain in blockchain. Each new block holds a unique digital fingerprint, a hash, of the block that came right before it. So block 3 is cryptographically tied to block 2, which is tied to block 1, all the way back to the beginning. Now imagine you tried to alter something in block 2. Its hash would instantly change, which would break the chain connecting to block 3. The entire network would immediately see it and yell, "Nope, that's not right."
And that brings us to the absolute core of blockchain security, hashing. You can think of it as the cryptographic glue that binds the entire structure together. So, how does this magic glue actually work?
So hashing is basically a process that can take any kind of input, a single word, a whole book, even a giant movie file, and it smooshes it down into a unique fixed-length string of text. That's the hash. But the most critical part to remember is that it's a one-way street. You can never take the hash and work backward to figure out what the original data was.
Here's the simplest way to picture it. You take some text of any length, you put it into this special function, and what pops out on the other side is a hash value that is always the same length. It's a pretty simple concept, but what you can do with it is incredibly powerful.
Now, a lot of people mix up hashing and encryption, but they have totally different jobs. Encryption is a two-way process. Its goal is to keep things secret. Use a key to lock data, and use a key to unlock it. Hashing, on the other hand, is that one-way street we talked about. Its purpose isn't to hide the data, but to prove that the data hasn't been messed with. It's all about integrity.
But here's the thing, you can't just use any old algorithm for this. For a hash function to be secure enough for something as important as a blockchain, it has to play by some very, very strict rules. And these rules are what make it truly unbreakable.
So, there are 4 non-negotiable properties for a secure hash function. First, it has to be deterministic. The same input will always give you the exact same output. Second, it has to have pre-image resistance. That's our one-way function. Third, it needs collision resistance, meaning it's basically impossible for 2 different inputs to accidentally create the same hash. And finally, my favorite, it has to have something called the avalanche effect.
The avalanche effect is one of the coolest and most important security features. It basically means that if you change even one tiny thing in the original data, like one letter in a document, it will cause a massive, completely different, and unpredictable change in the final hash. This is what makes any attempt to tamper with the data immediately obvious.
And here it is in action. Look at this. The original sentence gives us that first hash. But look what happens when we change one tiny thing. We just add an S to the end of the word dog. The new hash isn't just a little different, it's a completely different universe. It's totally unrecognizable. That is the power of the avalanche.
Then you've got collision resistance. This rule makes it practically impossible to find two different documents, say a legitimate contract and a fake one, that would produce the exact same hash. This is a huge deal for preventing fraud because it stops someone from swapping out real data for fake data and hoping nobody notices.
And finally, we're back to pre-image resistance. That's just the official name for that one-way property we keep talking about. You just can't take the final hash and reverse engineer it to figure out what the original data was. This is what keeps the actual contents of each block and each transaction safe from prying eyes.
Okay, so let's put it all together. We've got the blocks, we've got the chain, and we have this incredibly powerful hashing that links them all. So how do these pieces all work together to create a system that we can actually trust?
Here's how it plays out in the real world. Someone requests a transaction. A new block is created to hold that transaction. Then, that block gets broadcast to everybody on the network. All the computers or nodes check it out to make sure it's legit. Once enough of them agree, the block gets cryptographically chained to the end of the blockchain and the transaction is permanent. Done.
Ultimately, the foundation of all this trust rests on three cryptographic pillars. We've talked a lot about hashing, which ensures the data is intact, but it works hand in hand with public-private key pairs, which prove your identity, and digital signatures, which prove a transaction is authentic. Those three things together, that's what creates the legendary reliability of the blockchain.
And that's really the big innovation here. It's a completely new way to build trust in a digital world, one that doesn't need a central bank or a big company in the middle. The possibilities go way beyond just cryptocurrency. So the real question for you is, now that you know how it's built, what could you build with it?